Good morning and good afternoon, and welcome to this conversation on Fronthaul, Backhaul, EXFO, and millimeter wave, and how they're changing to meet the challenges of CRAN and 5G. Today, I'm talking to Marquis Dorais. He is the Fronthaul Product Line Manager at TD Metro and Access Business Unit at EXFO. Marquis, thanks for being with us today.
Thank you, Monica.
So tell us a bit about what is that you do at EXFO with respect to Fronthaul and Backhaul, and what you do also personally.
Okay, well, first of all, maybe just talking a bit briefly on EXFO and who we are, what do we do, and I would say in the test and measurement industry. So EXFO has been in business for 31 years now. We really started, our roots really started in the optical testing field, if you want. And today we're number one in terms of test and measurement on the optical side. And from there, we really, I would say we really evolved towards what we have today is really an end-to-end test and measurement solution for entire networks. And our goal here at EXFO is really to help our partners, I always say partners, but the service providers, mobile network operators to really deploy, I would say, their networks faster and more efficiently. And the way we do that is that we provide what we call intelligent and automated test solutions. And something that we often talk about at EXFO is test orchestration. And we have a portfolio that really offers what I would say is smarter solutions that really automate complex routines, often complex routines in terms of testing. And we automate those routines into simple applications. And this is really, the goal there is really to improve the overall network deployments for our service providers or for mobile network operators. And on the other side, on the flip side of that, we also have what we call network and service assurance solutions, really network probes that provide 3D analytics. And when I talk about 3D analytics, it's really something that is able to capture all the network data. So with these probes, we capture network data, and we provide the captured information in a really smarter way to really give network operators an overall view in terms of, let's say, in terms of network, in terms of service, and also at the subscriber layer. So really a 3-dimension of the network overall view. And the goal of that, when we talk about 3D analytics, is really to help our customers make better business decisions. So better business decisions in terms of being able to address issues quickly and accurately based on the information that we collect from our network probes. So we really work on both sides in terms of test and measurements.
Yeah, and that's very interesting because what Backhaul and Fronthaul, increasingly Fronthaul, are, in the industry, they're changing their role. I mean, obviously the function within the network is the same, but the role that they're taking is different. And I'm sure you've seen it in your experience. Can you tell us how you see that changing? It's the balance between Fronthaul and Backhaul, the different types of requirement. What is it operators are doing with that?
That's a good question. And maybe before I dive into that question, the specific question about Backhaul and Fronthaul, I would just like to quickly define what is Fronthaul, what is Backhaul. So Backhaul is really the portion of the network where I would say it's from the core of the network right up to the mobile equipment, so mobile base stations, if you want, or the BBUs, the baseband units. And the Fronthaul is really a new type of network where it's defined from, again, that piece of equipment, that piece of hardware, where it would be the base station, let's say at the bottom of the tower, right up to the top of the tower, where you have the remote right ahead and the antennas. So that's the Fronthaul portion and the Backhaul portion. And for us at EXFO, we have test solutions on both sides, so Backhaul and Fronthaul. And if we talk first on Backhaul side, we have portable test solutions that really help our customers ensure that the service that they're paying for, in terms of backhaul service that they're getting, is meeting their SLAs. So when I say SLAs, I really mean service level agreements. So metrics that we can ensure that they're meeting those SLAs. So SLAs could be in terms of latency, it could be in terms of jitter, it could be in terms of throughput, or it could even be in terms of, I would say, network configuration. So from the backhaul perspective with the portable test solution, this is what we're able to provide mobile network operators and service providers on that side. We also, a bit as I explained earlier on, is that we have network monitoring probes. And those probes are not portable, they're more static, they're placed inside the network to really crunch the data that it collects and to provide analytics for the service providers that are offering those backhaul services. So we have a wide range, I would say, of solutions on the backhaul side, so portable to network probes. On the fronthaul side, again, the portion of that network from the BBU, the baseband unit, to the remote right ahead, the part of the equipment at the top of the tower or the rooftop, well, we have a portable test solution on that side, and it's really designed to help for deployments and troubleshooting, depending on the phases that the mobile network operators, the MNOs, are in. And what we've seen based on our experience is really with the evolution of the RAN network, the radio access network, is there's a need now for fiber-based fronthaul testing solutions, because now it's fiber-based. And those testing needs are first and foremost on the fiber inspection at the connector level, ensuring that connectors are clean. This is really the basis of a good fiber network. Also ensuring that your fiber span, your complete fiber span is good and solid. There's no macro bands, there's no dirty connectors, damaged connectors. And this is something that we have had experience, as I mentioned before, over 31 years of experience on that side. So we have very, very automated solutions to quickly pinpoint exactly in terms of location and the type of issues that may arise. As I said, maybe a macro band 10 kilometers away. This is something that we could easily identify with our test solution. So, and moving along towards that fronthaul test solution is what we call the CPRI link validation. So something that's able to actually simulate the protocol that's running on the fronthaul to be able to actually talk to that remote right ahead, the piece of equipment that's at the top of the tower, to be able to validate that complete link. And when we're validating that link, it might sound simple, but there's often issues at the top of the tower in the sense that the SFP, the optical module that's placed inside the remote right ahead, may not be properly inserted. The fibers inside that SFP, inside the remote right ahead, may be damaged, maybe not fully inserted. And we also have to remember something that when I started working in the fronthaul business, if you want, is that when you start working with the tower top guys that work there, I mean, sometimes you could see antennas that are, towers actually that are maybe 250 feet tall, so 40, 50, even 100 meters tall. That tower is moving, there's a lot of wind, there's a lot of potential issues that may arise at the remote right ahead. So we have a test solution there, what we call the CPRI link validation, to be able to quickly identify, is that link running properly? Is the remote right ahead running properly? All those key metrics that are important to identify earlier on during the installation, and especially when the tower top crew is still at the top, because you do not want them to come back down if the complete installation has not been properly validated and tested. And this is something that's very, very costly for mobile network operators. And finally, the last piece of, I would say, that puzzle is really what we call RF spectrum analysis over CPRI. So capabilities on our fronthaul test solution to be able to see what the antenna is seeing in terms of RF. So being able to see all the RF spectrum, all the frequencies that are being used, and see that if there is any issues in terms of RF interference, in terms of PIM, passive intermodulation, a type of interference, with our solution, we're able to accurately and quickly see all those types of issues. So we do have solutions on both sides, the backhaul and the fronthaul side.
How do they balance each other in the sense that, you know, it used to be mostly backhaul, and now there is an increasing importance of fronthaul, but also the fronthaul becomes encompasses a bigger part of the transport because of CRAN and the increasing virtualization with 5G. That is going to come with 5G. How do you see this transition towards a transport that it's more heavily relying on fronthaul?
That's a good question, and really in that sense, what we're seeing is, I mean, everybody's seeing it in terms of mobile data growth. It's exponential. Every quarter, every month, it's growing at an exponential rate, and this is really why 5G is being, if you want, designed, is being brought to the market eventually within the next few years. And I would say 5G in terms of objectives are really, really high. So if we look at a few key points in terms of what the standard body wants to accomplish in terms of 5G, they're talking about, in terms of speed, just the speed itself to, let's say, to a mobile device, talking speeds of 100 times faster than what we have today in terms of LTE or in terms of 4G. Also in terms of number of connected devices, within, let's say, a certain area, they're talking about over 1,000 times more devices for the same given area. So in terms of just sheer speed, sheer number of connected devices, 5G objectives are extremely high. That being said, because that's so high, there's also going to be a need for faster fronthaul speeds. And in that sense, we could talk about speeds on the fronthaul itself. Today, it's mostly going up to 10 gig with the eventual move towards 5G. The fronthaul will move to 25, 50, even 100 gigs. So extremely fast data rates, protocol data rates running on the fronthaul portion. And that does not exclude the fact that on the backhaul side, the backhaul will need to be able to support those faster rates. So a lot faster rates on the backhaul side also. So that being said, what we're seeing is that today with FTTA, fiber to the antenna, and the move to CRAN is really the evolution of FTTA, where FTTA was, from my point of view, is FTTA is really co-location, so base station on the bottom of the tower with an antenna at the top. Moving to CRAN, where that base station becomes centralized into a data center, let's say. So in that sense, it's really, really critical for mobile network operators to build a very solid foundation with FTTA and CRAN. Because what they're building today for CRAN will absolutely be used for 5G networks. And this is something that, again, I'm trying to emphasize, is the fact that building the foundation solidly today is extremely important, because 5G is coming. It's for sure it's coming. And the rates will be a lot faster, and there will be a need to have a very clean, a very solid CRAN FTTA fronthaul. So that means that having a test solution that is really able to test and validate FTTA and CRAN networks today is extremely crucial to allow for what I would say is a smooth transition towards 5G, because 5G is coming. And 5G will be built on the fronthaul infrastructure that MNOs are building today.
So basically what you're saying is that we need to build the fronthaul infrastructure today so that when 5G is ready, we are just ready to move on and it doesn't become a bottleneck, right?
Exactly.
Okay. Yeah, so this is quite interesting. And before you also talked about CPRI, and the question is that as we see the huge increase in capacity that is coming, so we know it's coming, is CPRI the best interface to deal with that kind of capacity level? What do you think about CPRI in terms of the future prospects for it?
That's another good question in terms of CPRI. Maybe just before going into talking about the details of CPRI, I just would like to talk about the fact that the fronthaul network is used to transport what we call digital RF. So it's used to transport what we call IQ data, and that IQ data is RF in a digital format. And there's two protocols today that are mainly used to do that on the fronthaul side, and two of those protocols is CPRI, Common Public Radio Interface, and there's also OPSI. OPSI is Open Base Station Architecture Initiative, and those two protocols are basically, for me, they're competing protocols, competing standards, a bit in the sense of like Beta and VHS were back in the day. So on that side, from what we saw, what we've been seeing all over the world, because we work with basically all the MNOs, the tier 1 MNOs in the world. From our visits or discussion, even with the network operators, the equipment manufacturers that design the equipment, CPRI is really 90 to 95% of the market today. So it's really CPRI-based protocols that are running over the Fronthaul. And probably the reason for that is that there was an evolution of the standard, the CPRI standard, from first when it was designed. So it was designed, both standards came about at the same time, early 2000, and CPRI really continued its, if you want, its development in terms of the standard itself. And today there's rates in terms of CPRI rates that are designed to support 24.3 gig of data capacity on the CPRI side, not on the IP side, but on the CPRI side, as opposed to upside, which today definitely the fastest rate on the upside side is 6.1. So CPRI is really designed today to support much faster rates. And we know that eventually the equipment itself, industry experts are talking today about is really having a solution that's a lot more flexible in terms of evolution of that protocol that's carrying information towards the remote relay heads, and it would be an evolution towards Ethernet. So eventually, what we're seeing is a move towards Ethernet. It's not here today. It's probably going to be many more years before the Fronthaul goes to Ethernet. And the main reason for that is, well, first, the groups that are working on that specific standard, there's a lot of questions that need to be defined, that need to be answered today. Second portion of that is really the fact that mobile network operators today are deploying equipment to meet the demands that are in place today. So for them to start changing towards something new, something that's not purely established in the market, I see CPRI being deployed for probably 3, 4, even 5 years from now, and also being supported for many, many more years. And as I said before, CPRI in terms of data rates, it supports much higher data rates. So as I said, 24.3 gigs, at some point it will be able to allow a lot faster IP data on that side.
Mm-hmm. So CPRI is going to improve, but at the end of the day, Ethernet might be prevailing in the long term, right? Now, what about from your point of view? What does it take to help operators deal with the Ethernet Fronthaul?
Ethernet Fronthaul. So in that sense, on our side, on EXFO side, as I said earlier on, is that EXFO has been a leader in terms of optical testing solution, in terms of optical test and measurement solutions. We also have a business unit that's very, very solid in terms of protocol. So Ethernet is something that we've been working with for many, many years, and it's not something new to us. So every time there's new technologies that are being standardized, this is something that we're at the forefront. We always work with the standard bodies to bring those test solutions to be able to test those new technologies. So Ethernet is not something new. As I said, on the backhaul side, if you want, this is something that we've been doing for years in terms of testing reliability, in terms of testing any key metrics in terms of Ethernet. So once the move is done towards having a Fronthaul that's Ethernet based, this is something that we will be there to support our customers. We will be there to educate our customers and really help our customers deliver, when that time comes, deliver Ethernet-based Fronthaul solutions. This is something that will be there to help and support our customers on that front. But as I previously said, is that from what I see today is that CPRI is there for many more years. It's not going to change overnight. The equipment that's being installed today is CPRI or upside based in some small portion. So there will be many more years of the CPRI deployments on that side.
Okay, now let's move the conversation a little bit about the cost benefit of testing. So you can look at testing and say, well, that's something we have to do, a check that we need to have. But on the other hand, having an efficient network, and this is increasingly becoming a concern, that you can increase the utilization ratio. It's very important in terms of profitability, in terms of cost savings and revenue opportunity. Can you comment a little bit about on how testing can benefit operators in terms of their CapEx and OpEx in a way that it just goes beyond the basic testing activity itself?
Yeah, okay. So something that I mentioned earlier on is that in terms of technology, the mobile space is something that's evolving very quickly. There's so much demand placed on mobile network operators to offer great services to their subscribers, and customers are quick to subscribers are quick to change mobile network operators. So in that sense, it's evolving quickly, and the MNOs have to adapt to that. So in that sense, field technicians on their side too have to be what we say more versatile. So they have to. There's a term in the industry talking about field technicians that have to be hybrid technicians. So capabilities to adapt to new technologies, new testing solutions on that side, and also on the mobile network operator side, they have to manage their OpEx better. They have to deploy faster, and they have to come out with services that will generate revenues a lot quicker. So this is something that we know is very important to them. So without having the right testing procedure, testing method of procedure, we call it a MOP, often at EXFO, where we work with our mobile network operators to have a method of procedure in place to be able to turn up and troubleshoot Fronthaul networks very, very quickly. And this is something that EXFO has been working very diligently at, is having solutions that are easy to use for cell techs, easy to use for RF performance engineers. And the idea behind that is that we know that as I said before, cell techs are asked to do a lot more than in the past. In the past, you would have maybe a cell tech in charge of RF, cell tech in charge of, let's say, the cabling of cell, somebody in charge of the backhaul for on the optical side or Ethernet side. Today, cell techs are being asked to be hybrid techs. So that's why we have test solutions that combine all those technologies in a very efficient way. And the idea behind that is really to reduce costs and reduce time in terms of troubleshooting and deploying. So in terms of CapEx and OpEx savings, let's say the benefits from testing, the idea for us is really to have simple solutions to really help them. And just an example of last week, while I was traveling to a tier 1 MNO, and we were working closely with their main contractor. And this contractor we've been working for many years with, and what we did with this particular contractor is we helped them develop a method of procedure, a way to actually, while they're building the cell tower, while they're building the Fronthaul, to have a method of procedure in place to be able to test quickly and efficiently, to make sure that when they deliver that new installation, it is done perfectly and there's no repeat calls. And this is something that we got the feedback last week, said ever since we've been, what they said is a CPRI link validation test. So they're doing connector inspection with a fiber inspection probe, which is purely automated. They're doing also OTDR traces, so actually characterizing the fiber. So in their case, initially they were working on FTTA, so short runs. Now they're working on CRAN deployment, so longer fiber spans. So while they're doing fiber inspection to characterize the fiber characterization with the OTDR that we have, and also CPRI link validation, now they know that when they deliver a cell site, they do not get repeat calls from their tier 1 MNO, the tier 1 MNO that they're working with. And overall, what this in turn leads to is total cost savings. Total cost savings for the MNO, total cost savings for the contractor that's working on these deployments, because they get more repeat jobs from this contractor. They also are considered number one in terms of being able to deliver all these services. And in the end, the MNO does save a lot in terms of having a system that's ready to go when the site is turned over to them. So for them, just the benefits of testing is tremendous. And also quickly on that side is we worked with a tier 1 operator in Europe, where what they did there, we were invited to a CRAN field trial. And at that CRAN field trial, it was really a field trial to go over the complete installation, make sure that everything is running right before they place that CRAN field trial into a deployment phase. So while we were there, we were invited there to actually help them and basically show them how they can actually improve the way they deliver, they install that complete CRAN Fronthaul. So in that case, what we did is we went through the various testing procedures that we recommend. So first off is looking at the connectors. And in this case, because there was CRAN, the fiber span was a lot longer. So this is something that moving towards FTTA, moving towards CRAN, something that we see is becoming a lot more critical is having a proper testing procedure. In a lot of cases, what we see in many areas, many regions, is that they typically, for Fronthaul, did not have a testing strategy. So it was a no-test strategy. What they noticed is that they were getting repeat calls, repeat visits, and now with having a systematic method of procedure, a way to test the installation, test and validate the complete installation, now they're seeing a lot faster time to revenue, a lot faster turnaround time when there is issues, when you have the right test solution to test that Fronthaul. So in that particular case with that CRAN field trial, we were able to show them connector inspection, which was easily done within a few seconds. And this is something that, especially moving towards CRAN, again, I know I mentioned this before, but with CRAN, a lot longer fiber span, so a lot more potential issues with the fiber network itself. So first off, fiber inspection, that CRAN network. Second step was really validating, characterizing the full fiber span from the data center. In this case, it was a data center interconnected to a remote read-ahead that was 8 kilometers away. So having OTDR type of solution that we have, all integrated in our Fronthaul solution, where they were able to actually pinpoint exact location of missing interconnections. And this is something that we saw. There was 2 missing interconnections within that Fronthaul deployment. Mislabeling of fibers. Again, these are all issues that may sound simple, but when you're moving towards CRAN, again, longer fiber spans, these issues will increase. They're not diminishing, they're increasing. So it's really, really important to have a good method of procedure when you're deploying, especially moving towards CRAN, where those fiber spans are a lot longer. So quickly going through that, we were able to pinpoint exact locations of missing interconnections. We're also able to do what we call as a CPRI link validation. So we're able to simulate, we were able to, at the BBU side, we were able to actually validate the CPRI ports in terms of configuration, in terms of SFP being used. We're able to validate the BBU was operating correctly in terms of those rates. This is something that we saw. One of the equipment was not configured as expected. So misconfiguration on that side. We were also able, on the RH side, so the remote read-ahead, the equipment at the far end site, we're able to also validate that the equipment was running properly. In that case, we found issues there too. So we found the fact that there's often 2 ports on the remote read-aheads, the equipment at the far end site. There's 2 ports. There's usually a primary port and a secondary port in terms of the optical ports that are used on those remote read-aheads. And in this case, the field technician had used the secondary port. And this is a mistake that can easily happen because in terms of labeling on the equipment, in terms of it was placed in a dark room, it was difficult to see CPRI 1, CPRI 2, those 2 ports, and it was placed into the wrong CPRI port. It sounds simple, it sounds easy to correct, but if you don't have the right testing solution, you're going to spend time looking at the fiber, you're going to spend time looking at the optical transport link itself. In this case, it was a multiplex with many different wavelengths. You'll spend time looking at the BBU equipment, so spend time looking at the RH equipment, and if you have the right testing solution, like in our case, where we're able to quickly identify you cannot get a CPRI link up at your RH, let's look at the ports that are being used. We found that the port was not properly, properly connected. So we switch the SFP to the correct port. We're able to quickly get that whole system up and operational within a few hours, instead of, as we saw, instead of many hours or even days just to bring it up in operation. So having the right test solution, especially going towards CRAN, is critical, and it provides a lot of benefits in terms of cost savings and time to deployment.
Absolutely. And so if we look at what's coming next in terms of hearing what is that the operators need over, say, the next 5 years, and what you are planning to do, what's going on there? So what are the operators want, and what is it you can do to help them?
Yep. So what we're seeing today, at least on the Fronthaul side, this is an area where I really focus on, is in terms of new demands, new needs. What we're seeing there is that during the installation of let's say the Fronthaul, the piece of that network interconnected to the antennas, in a lot of cases, while they're doing this installation, the equipment at the bottom of the tower is not there. So the BBU, or the baseband unit, is not present. And one piece that they do need is something to validate that, in terms of the link, in terms of the RF performance of that site, if you want, is operational without having a BBU. So this is something that we call BBU emulation. This is something that we do have those capabilities there, and we're adding further intelligent capabilities on that side. So capabilities for, let's say, the MNO cell tech, or even the contractor, to come in without having access to a baseband unit, a real baseband unit. They have our equipment, our test solution, to be able to validate a complete link, start transmitting over the RH, over the air, and looking at the RF spectrum, looking at in terms of performance, in terms of, is there any RF interference on that system that's being installed. Also looking at, let's say, the tilt of the antenna. Is that the correct tilt? Can you adjust the tilt? So a lot of pieces that need to be addressed earlier on during the installation phase. So today, without having BBU emulation, you have to wait for the MNO cell tech team to come in, install the BBU, place the BBU into operation before you know that everything is operational. Having BBU emulation on our test solution provides them early visibility in terms of, is there any RF performance issues? Is there any equipment issues? So this is part of the, if you want, the latest technology in terms of Fronthaul test solution. Also, we're looking at the Ethernet side. As I mentioned, this is something that's further out in terms of having Ethernet over the Fronthaul network, but this is something that we're following closely, and we're positioning ourselves in a way to be ready for when the time comes, once the standard is fully defined, we're able to come in with a solution to actually test the Fronthaul portion over Ethernet, test that link, test also in terms of RF performance, having those capabilities there over Ethernet. And this is something that we're looking closely at. And for sure, as I mentioned, something that I mentioned many times throughout this interview, is the fact that EXFO is known to having solutions that are simple to use and very, very automated. And this is something that we're bringing on to our Fronthaul test solution, is a lot of automation. So we have a lot of automation in terms of the optical portion. We're bringing a lot of automation in terms of the protocol, in terms of the RF validation piece. This is something that we're going to be bringing to the market with this solution there.
Well, that's very interesting to get your perspective on the testing. It's clearly a crucial part in making sure the networks work well, and you get most of the benefits from that. Well, Marquis, thanks so much for sharing your thoughts with us today. It was a pleasure talking to you. Thank you,
Monica. Thank you for having me.
Okay, and this conversation was part of a report by Sensafili in collaboration with RCR Wireless News on backhaul, fronthaul, different types of axial and millimeter wave. Thank you all for listening in, and you can download the report as well from the website.